Hello. All right, can you hear me? All right,
yes,
cool.
Loud and clear.
Sound check. All right, hello everyone, and welcome back to another episode of PyTorch Community Voices. This is a weekly webinar where we get to showcase builders in the PyTorch community and have them come on and get to share about the projects that they're working on. So I'm one of your hosts, Jessica. I'm a developer advocate here at Facebook, focused on our AI ML open source projects. And with me here is Suraj.
Hey everyone, my name is Suraj Subramanian. I'm a developer advocate working with PyTorch. Thanks, Jessica.
Yeah, and we're very excited to have you guys here to join our two guests, Michael and Richard from Anyscale. So Anyscale, they're here to share with us about Ray, which is an open source framework for building distributed Python applications that really pairs well with PyTorch to rapidly scale machine learning applications. And so Ray provides several libraries that are focused on solving several of the most common challenges for scalable machine learning, including hyperparameter tuning, reinforcement learning, distributed training, and serving all at scale. So yeah, we're really excited to have them on. So I'm going to pull up Michael and Ray right now. Hey guys.
Hey, welcome.
Hey,
welcome.
Thanks for having us.
Yeah, could you guys give the audience a quick intro of you guys? Maybe we'll start off with Michael. He's on my
Sure.
right.
So hi, I'm Michael. I'm a developer advocate working on sharing everything Ray, and I'm really excited to be here.
Nice. And then
hi, my name is Richard. I'm a core maintainer of the Ray project. I've been working on Ray for the last 4 or 5 years, and right now I work at Anyscale, leading a team focusing on machine learning libraries and scaling these out on top of Ray, and then also making sure that Ray is deployed at various companies for machine learning platform use cases.
Nice. So yeah, well-rounded perspectives here.
Thanks, Michael and Richard, for taking the time out today. Usually the format that we follow in the show is that for the first 15 to 20 minutes, you guys on front stage. You share what you have about Ray. And meanwhile, the audience types in their questions as you are presenting in the chat on the side. And once you're done with the presentation, we'll open up the floor and we'll just have a free-flowing conversation with the audience and yourself, and just answer whatever questions that come up.
Sounds great.
All right. Okay, I'm really excited to hear you speak about Ray. Distributed machine learning is something that is so important today. I know you're going to be touching upon why that is so, and also what the solutions are. So without any further ado, it's all yours.
Thank you so much. So hello, everyone. So this is the talk portion of today's PyTorch Community Voices. So let's get into what this talk is about. So the general premise of this talk is that machine learning today requires distributed computing. Whether you're training networks, tuning hyperparameters, sorting models, or processing data, machine learning is computationally intensive and can be prohibitively slow without access to a cluster. Where Ray comes in is that it's a popular framework for distributed Python that can be paired with PyTorch to rapidly scale your machine learning applications. And so before we get to what Ray is in depth and how to pair with PyTorch, it's important to take a step back and briefly discuss why we need distributed computing. The plot shown is from OpenAI, and it shows compute demands to train state-of-the-art models between 2012 and 2020. The growth rate is staggering, roughly 35x increase every 18 months. It's important to note that the graph is in log scale. This next slide shows Moore's Law. Moore's Law has powered the tech industry for decades. Processing performance has doubled every 18 months. While 2x is certainly impressive, it's not 35x. Moore's Law is also likely slowing down, as even Gordon Moore has stated. It cannot continue forever. Also, it's worth mentioning GPT-3. The model has 175 billion parameters. It's the largest model released by OpenAI. It's clear that compute demands and memory requirements are rapidly increasing. Let's now look at specialized hardware like GPUs and TPUs. And while the performance of GPUs and TPUs brings more computational power to the table, they essentially help to prolong Moore's Law further into the future, not to fundamentally increase the rate of improvement. They aren't matching the increased demand on their own. To support these workloads, it really helped to distribute these apps. The major problem is that distributed computing has traditionally not been that easy. So there's really no way out but distribute these apps. And that's where Ray comes in. Ray is an open source library for parallel and distributed Python. It's also an ecosystem of libraries for scaling machine learning, model serving, and much more. It also contains tools for launching clusters on any cloud provider. One of the major advantages of Ray is that it's simple. It really makes it easy to scale your Python applications without rewriting them. And that same code can run on one machine or multiple machines. Additionally, as really important in distributed computing is that Ray gracefully handles machine failures. Of course, while all that's important, perhaps the most important thing is that tasks run with millisecond latencies can scale to tens of thousands of cores. Recently, Ant Group gave a talk on deploying financial services with Ray on 200K cores. So much like PyTorch has its own ecosystem, Ray has its own ecosystem which intersects with PyTorch's. The image shown is a depiction of the Ray ecosystem. At the lowest level, we have the core Ray API. That's an API for taking Python functions, Python classes, and translating them into a distributed setting. It's very general, and you can build arbitrary applications on top of Ray. I should note that if you want to learn more about the core Ray API, check out A Gentle Introduction to Ray. And because Ray is a universal framework for distributed computing, it's very general, and that generality is really important for supporting the library ecosystem. The ecosystem covers everything from training to production serving to data processing and more. As you see in the image, Ray supports PyTorch, and this ecosystem is primarily what we're talking about today. I should note that by running multiple libraries together on top of Ray, you can use multiple libraries together and build applications that do all of these things. Also, by using Ray, you can run your applications anywhere, on any cloud provider, on Kubernetes, or even on your laptop. And each of these components together add value for the users of the other components. And while a lot of libraries in the Ray ecosystem have first-class support for PyTorch and require minimal modifications to run your code with PyTorch, I'll briefly go over some native Ray libraries like RayTune and how they can interact with PyTorch. So RayTune is a library for experiment execution and hyperparameter tuning. There's a couple major benefits like the ability to run multi-node distributed hyperparameter sweeps in less than 10 lines of code. There's also support for every major machine learning framework, including PyTorch, as well as first-class support for GPUs. Additionally, there's other features that people like that include automatic management of checkpoints and logging to TensorBoard, and of course, access to state-of-the-art algorithms such as population-based training, which you can see on the right side of the screen, base op search, and hyperband Asha. The next question you might be asking is how to actually get started with PyTorch and RayTune. Since this is a PyTorch audience, my first recommendation is to start with the PyTorch documentation. There's a tutorial in it for training a Safari 10 image classifier using Asha. Compared to the original version of Hyperband, this implementation provides better parallelism and avoids straggler issues during eliminations. And of course, you can also check out the Ray docs. I should also note that most of the uses of RayTune and PyTorch require minimal modifications to your PyTorch code. Sometimes you have to do things like wrap data loading and training functions, make some network parameters configurable, add checkpointing, and a few other minor little things. So we'll next talk about RLlib, which is a reinforcement learning library. It offers both high scalability and a unified API for a variety of applications. There's some major advantages including, of course, native support for PyTorch, support for model-free, model-based, evolutionary, planning, and multi-agent algorithms. And there's being more added all the time. There's also support for complex model types, such as attention nets and LSTM stacks via simple config flags and auto wrappers. As far as how to get started with RLlib, my absolute favorite way is the RLlib hands-on RL with Ray's RLlib tutorial. It's freely available at Ray Summit and soon to be on YouTube as well. It's a great beginner's tutorial for getting started with reinforcement learning in RLlib. And of course, if you prefer documentation, that's also a good place to start as well. So there are other challenges to scaling machine learning applications than just training. For instance, model serving and inference. So on the surface, serving a machine learning model should be exactly like serving some web function that queries a database. After all, a web request comes in, it gets sent to some black box, like a machine learning model in the database, the server gets the result from the black box, and then sends out a web response. It should be that simple. Unfortunately, there are drastically different ML models. ML models are drastically difficult to configure, compute intensive, and more. They often have response times in the tens of milliseconds or higher. A single query can use up 100% of a GPU or CPU and a lot of memory. While a single web server accessing a database can achieve at least 10,000 queries per second, a web server serving machine learning models may only achieve 10 to 100 queries per second. Furthermore, machine learning models are generally loaded only once per serving process. If the state is corrupted, the entire process goes down. So this is where RayServe comes in. It's an easy-to-use, scalable machine learning model built on top of Ray. It's framework agnostic, so you can use a single toolkit to serve everything from deep learning models built with frameworks like PyTorch to scikit-learn models to arbitrary Python business logic. It's also Python first, so you can build and configure your model serving declaratively in pure Python without needing YAML or JSON config. And one of the most biggest things about RayServe is that it's compatible with other libraries like RayTune and FastAPI. And since RayServe is built on Ray, it allows you to scale to many machines, both in your data center and also in the cloud. To get started with RayServe, the PyTorch tutorial in the RayServe doc is a nice place to start. It shows how to load and serve a PyTorch ResNet model. There's also an amazing PyCon talk called Patterns of Machine Learning Models in Production by Simon Moe. It's super informative in terms of learning RayServe and just deploying machine learning models in general. It's one of my favorite talks and something I reference often. The final library we'll talk about is RaySGD, which provides distributed training wrappers for data parallel training. It allows you to scale PyTorch's distributed data parallel without needing to monitor individual nodes. It's scalable. You can scale up and down. You can start on a single CPU, scale to multiple nodes, multi-CPU, or multi-GPU clusters by changing 2 lines of code. There's accelerated training. So there's built-in support for mixed precision training with NVIDIA Apex. And like most Ray libraries, it's fault tolerant. There's support for automatic recovery when cloud machines are preempted. And finally, there's seamless integration with other libraries like RayTune and RayServe. Of course, there are a variety of ways to get started with RaySGD and PyTorch. The first link is all you really need, distributed PyTorch in the Ray docs. But if you want to learn more about Ray in general and how it can compare with PyTorch, the Getting Started with Distributed ML with PyTorch and Ray has a nice overview. It's in the PyTorch blog. So Ray has an incredibly broad user base and equally broad use cases. Some people are using Ray to build scalable infrastructure for financial services. Others are optimizing recommendations in and out purchases. And others are doing large-scale machine learning on aerial imagery and much, much more. Just for a minute or two, I figured I'd share a couple interesting uses of Ray. Denture Systems uses Ray for ecological restoration, for providing the compute infrastructure, the training, the inference, and computer vision at a tremendous scale to plant trees. Recently, McKinsey and Quantum Black partnered with Emery's Team New Zealand and designed the boat in this picture, using Ray and PyTorch to do reinforcement learning. In doing that, they won America's Cup, which is the top competition in sailing. It's really amazing what you can build with PyTorch and Ray RLlib, and of course, many different libraries working together. If you want to learn more about this, you can check out Nicholas Holmes' Ray Summit talks. And while these use cases are certainly impressive and interesting, it's also important to mention that there are a lot of end users who are individual developers, hobbyists, and researchers. We have hobbyists trying to get their robot to do RL or some parallelizable task. And in a recent AnyScale Connect session, we had a professor from Rice University use Ray to scalably reduce the time it takes to encrypt or verify an election from hours down to minutes. And that concludes the presentation. Any questions?
Wow, okay, 1 second. Adding everyone back. Nice. Great presentation, Michael.
Thank you.
Okay.
So I think our audiences has peppered us with a few questions.
Sure, feel free to ask. And we can also have Richard answer some questions too.
Tyrone asks if Ray can be distributed to AMD GPUs on ROCm.
Oh yeah, so I would say right now, like the support for GPUs is largely on the NVIDIA side. But right now we're focusing a lot on making sure we have at least ARM wheels, so being able to support different architectures, and then we'll slowly expand into more use cases such as like RLCM. But right now this is not yet supported. But do feel free to file feature requests on GitHub. We'll be sure to take those into account.
Nice. Well, speaking of GitHub and links, so Tyrone's asking a couple of questions about the resources. So speaking of GitHub, there's a link for the project. It should be down below if you're watching on YouTube and Facebook. But for the other documents that Michael had mentioned in your presentation, do you think this is if the presentation is something that could be shared publicly? That'd be great. Okay. Yeah, then yeah, we'd love to. We'll definitely add a link to those to the resources down below after this presentation. Then.
I'll share some of the links when people are asking right now.
Okay, thanks. And with that, I think Suraj, you had a question.
Yeah, Michael, you mentioned Simon Moore's talk on
Mhm.
patterns in production, machine learning production.
Mhm.
So did you have any thoughts on how, what are the guiding principles when you're choosing the kind of design pattern that you opt in for productionizing your machine learning models?
I can have Richard talk more about this, but for me, the biggest thing is choosing the framework. Like, do you have to configure your model for serving on a specific framework? Do you have to change it a lot? So how much effort goes into that? Is it scalable? That's probably the biggest thing. Can you scale your model when you serve it? Richard, what about you? What do you think?
Yeah, I think one of the things that I would point out is Torch does actually have a great built-in solution called Torch Serve, right? And that's very, very flexible. It runs really well with Kubernetes. I would say for many industries, though, it happens to be the case that you want a unified serving there, but you also have more libraries than simply PyTorch. You might have something like XGBoost. You might have some TensorFlow. Just like a variety of different machine learning frameworks. And if you want to have something that's sort of a model like agnostic to the framework, as Michael said, there's a subset of solutions that you can choose from. Now, among the subset of solutions, I think another thing that you want to think about is how like generalizable and how future-proof is this framework. And there's a lot of solutions that rely heavily on Kubernetes, which is great and obviously like probably the de facto standard right now. But I would say that one of the things that's very complex to do on these frameworks that tie themselves really deeply to Kubernetes is the need to, when you want to do something a little bit more complex, right? Like say you want to have like one model which does like feature ingestion, and you have like a bunch of different models that predict different parts of the user outcome, and then you have some model that combines it all together. Like this sort of composition and this sort of like thing is actually quite hard to do on Kubernetes, but it's really easy to do with Rails. And so when we think about Rails Serve, I think really it's like flexibility is the main thing that comes to mind: flexibility and scalability. So being able to like take any sort of framework and plug it in and do arbitrary like scalable patterns.
Mm-hmm. So that includes like scikit-learn, XGBoost, PyTorch, whatever you have, you want to be able to serve it. Even just like Python business logic, like simple stuff.
Yeah, I thought that was pretty interesting when I was going through the docs, that this is not limited to any particular framework. It's just general distributed Python.
Yep.
You, if I may follow up with one question, you also mentioned that you mentioned Torch Serve, and I was wondering, what do you think about the comparisons between Rails Serve and Torch Serve? Like, which solution should people opt for, depending on the kind of use case they're targeting?
Yeah, so I think for this particular question, I would go with this like idea of the principle of least power. So you should choose a tool that is like the most applicable for your use case and not more than what you need, unless you have some sort of future need, right? And so if you are a small company or like a small researcher who wants to do a small project and really just has one model, like a resonant model that they want to serve, there's no reason why Torch Serve can't serve your use case, and probably serves it very well. But once you get to a little bit more complicated use cases, such as say like the sort of examples that I provided, then you probably want to look somewhere else, and Rails Serve might be a great place to look at.
Interesting. I actually wanted to jump in with a question about. Sorry, I was kind of blanking on questions on my question. I think to the point of you guys are it's impacting so many different types of companies. So like that slide that Michael had shown, and then recently you guys had the Rate conference for folks who, just doing a plug if people want to go and watch those presentations. But I actually wanted to ask maybe like a more abstract question, but how has Ray been shaping the industry, given that you work with so many different types of companies, from like financial to like logistics?
Yeah, I can quickly answer that question. I think there's many different ways, like different patterns where we see Ray really shaping the way things are being built. And I think the two examples that come to mind are reinforcement learning and also machine learning platforms. We're starting to see a new generation of like large companies and even small companies who are looking at their current stack, right, for doing a machine learning end-to-end workflow. And their current stack actually just consists of a zoo of different frameworks. You might have Spark for the data processing. You might have PyTorch, some homegrown solution for scaling PyTorch. You might have another homegrown solution for doing like XGBoost training. You might have another homegrown solution for doing like serving. And one thing that Ray is doing is is basically becoming this like one single layer upon which a bunch of different these workflows are able to port onto. And so because it's super Pythonic, now you have a bunch of data scientists who previously need to rely on different teams to do this sort of like scout. And now instead of doing that, now they can start doing very complex, distributed mechanisms on one single, on one single framework, and it's very Pythonic. So that's also pushing the boundaries of what people were previously thinking about doing in the first place. So machine learning platforms, to summarize, machine learning platforms and this consolidation of the stack in this machine learning platform space is one way that Ray is really shaping the industry. And the second case is with reinforcement learning. There's just no good way of scaling out reinforcement learning models except for using Ray's RLlib library. And this becomes really, really impactful because reinforcement learning has been sort of on the rise for the last 5 to 10 years. And it's only now where people are really considering and spending the research, R&D efforts in investing in reinforcement learning, especially like gaming companies, right? And now that they're getting some returns, they want to start scaling out. And without RLlib, everyone would be building their own solution, or like it's possible people might just give up. With RLlib now, it's like, well, we're seeing like huge wins in certain domains, such as the America's Cup, such as, like gaming companies, such as, oil drilling companies, and so on and so forth.
And like offline reinforcement learning and just like a variety of use cases of big companies, small companies. Like we've had Microsoft do offline reinforcement learning, and we've had, researchers at MIT doing like neural MMO with RLlib. So there's a lot of fun different use cases out there. They're all available if you want to like see talks about it. You can go to Ray Summit and see like one of the 50 talks we've had, Richard, or so this year. It's a lot.
It's almost like RLlib is kind of standardizing how reinforcement learning is done in distributed environments.
That's right. That's right.
And that's a huge contribution to the industry, I would say.
Yeah. I mean, it's pretty exciting. Like when we started building RLlib, it was like basically a research. I mean, it was really just a research project, right? Like we just thought, hey, look, like DeepMind has all these cool papers. What if we just like built one framework to rule them all, for fun? And then it ended up being like, okay, well, actually we can make this really legit. And then we could just like take it out and go to different companies and turn it in. Suddenly like a bunch of other companies are starting to use it.
Wow, that is so cool.
Yeah. Was that really the start of Ray, Richard? Like RLlib was the use case originally?
RLlib was, I would say it was one of the early use cases of the Ray core project. Yeah.
I want to let a question in from the audience. Alma Moon asks, is there any paper for the implementations in Ray?
Yeah.
Or maybe the distributed implementations, and what graph type do you use? Thank you.
So I guess I can answer this question. So there's multiple papers on the Ray project. I would say there's like a original Ray core paper that was published in OSDI, which is like a top systems conference. RLlib was published at ICML in 2018. RayTune was published in I think it was also like an ICML workshop in 2018. RayServe has not had a publication, but I don't think it's not necessarily the case that every project corresponds to a publication. How do we distribute the work? We use gRPC underneath the hood, and And then we also, write a couple, like we use Arrow to do serialization. We have different parts of the data stack to do, data transfer. And then what type of graph do we use? I'm not sure how to answer this question. We have our own internal like Ray has its own internal representation for graphs, for program graphs. Yeah.
All right. Thank you, Almamoon. Tyrone asks this question. My solution is to pickle the model and send that through the API. I have to confess that's exactly how even I would be doing it. I just pickle the model and deploy it on a Flask server. And when the model sizes started to grow and the inference time started to get much more, I realized that I need to look at other solutions. And I think Tyrone seems to be in the same boat. He wonders when should he use Ray versus, I think he means TorchServe.
Mm-hmm.
Yeah. I mean, I think we touched on this question earlier. Yeah, but like, I think what you said is right. Like, if you're gonna like hit this endpoint like once a week or whatever, pickling the model and sending it through the API would probably work totally fine.
Yeah, it also depends. Are you doing like a complex model type? Are you doing like A/B testing? Are you doing like a cascading model type? Like there's, if you're curious about more like cascading and A/B testing and stuff, just watch the Racer Patterns of Machine Learning Production talk. It's really great. I probably pitched that too much, but it's a really great talk.
Michael, maybe we can add a link to that talk.
Sure, I'll send it right now.
Okay, thanks, Tyrone. I did want to ask you a little about the future of Ray. So right now, the Ray ecosystem has libraries for distributed parameter tuning, distributed training, distributed inference. What's next? What's next for Ray?
Interesting question. I think what we really want to do is really also focus on distributed, like we want to sort of expand the use case of distributed training. I think Ray SUD is like an initial library, and we also have integrated with PyTorch Lightning. But I think like doing distributed training on top of Ray, with whether it be like TensorFlow, PyTorch, or XGBoost, this is something that users have wanted, like is a very high priority user request. And that's something that we're going to really focus on and providing really good, add-on functionality for people who are really trying to scale out on top of Ray. I think another thing is like thinking about how we can sort of bridge all these different solutions together, right? Like we have people like Tyrone who are asking about, okay, how do we do like serving on top of Ray? And then we have different users who are asking like, how do we do tuning on top of Ray? But I think one thing that we really want to think about is like, what does the interoperability story look like? How do you get from like a model serving, like what happens if you want to do like model serving and then after a while you want to like retrain, right? Like that sort of question.
Right.
And that sort of interface, like what's like the most native Ray-based API or like user-friendly API that we can provide.
Like a one-stop shop.
That would be cool. Yes.
That'd be ideal.
Nice. For those who are joining us now, we have Richard and Michael from Anyscale talking to us about Ray, the library for doing distributed computing in Python, and not just any framework in machine learning. Though Ray does have very specialized bindings to make life with distributed PyTorch much easier. So do post in your questions in the chat. Richard and Michael are currently doing a Q&A. And
well, I guess while we're waiting for some questions to come in, can I just ask kind of a general question?
Sure.
Can you guys speak to maybe what's something about machine learning in general that's exciting to you? Things that are coming down the pipeline, things that maybe you're working on now.
I'll start with this. It's a pretty generic answer, but for me, I'm really excited about model interpretability because back in the old days, I mean, it was really hard to sell anyone on machine learning unless you can explain how the model works. So model interpretability is like definitely one of them. I also really like how easy it is to get started. So like Richard is like, he has a lot of technical knowledge in a lot of different use cases. And what I really like about, working with at Ascale and with Ray is that it's really, really simple to get started now. Like I don't have to have major distributed computing knowledge to get started with Ray, to get started with PyTorch, because there's a lot of great resources out there. Whereas I would argue like 10 years ago, it was a little more difficult to get started. What about you, Richard?
Yeah, this is interesting, or I guess a little hard question for me. There's like so many things about machine learning that's so exciting. But perhaps like something that is more like AI assisted like living, I think that's like very, very exciting to me. So for example, like there's this like spoon. This is like some random product that I've seen on the internet, but like, you have people who have, motor controls, like motor skill disabilities, and they have like this inability to hold a spoon properly. But with like, proper controlling and proper, micro robotics plus machine learning, you can have like this really, really stable sort of tooling, and now the person can feed themselves, which is like really, really radical. And that's something that's really exciting to me, just like, having the quality of life of everyone just being improved.
Yeah, it kind of reminds me of when we had the folks from, blanking now, Adobe on last time. Just kind of like the intersection between the software world and like the 3D actual living world. Like, so how are we using these like these newfound like capabilities to like actually manifest in our like physical lives. So yeah, I think that's interesting. And to your point about Michael about interpretability, I wanted to ask, are there any thoughts of if Ray will get into that?
Well, I can't speak about the roadmap for what Ray is specifically going into. We typically support distributed computing. However, that may come about whatever people are doing. Richard, do you want to follow up on this?
Yeah, so interpretability is interesting. I think there are libraries that are built on top of Ray, specifically Selden Alibi, I think, which is the interpretability, explainability library. There's no investment, no direct investment from the Anyscale side right now, but we obviously understand this is really important, and like having good compatibility with the ecosystem here is really, really good. Do you mind if I answer a couple of these questions?
Yeah, definitely. We're about to pick those up too.
I'm going to answer this question about from Yagia, which is the future of hardware accelerated AI processors work with Ray. So this is very interesting. I think what we want to do is we want to be future-proof here. We don't want to just only tie ourselves to GPUs, and we want to make it really easy to plug in a different sort of device. And this is some work that we're currently doing right now. We have some support for this, but I think this just needs to be brought a little bit higher to our attention. So if you could file GitHub requests for this, that would be great. So basically the answer is like in the future, this should be supported. Yeah. Great. Do you mind if we go to the next question, which is, are there any plans to add job queue support to Ray? So this is actually, I mean, thanks for bringing this up. This is very interesting. And just to give a little bit more context for the rest of the listeners, job queues are really useful when you want to do a variety of different things, and you might want to run multiple different jobs or different training jobs or train different models, but you have limited amount of resources, right? So for example, let's say you have 8 GPUs and you want to train all these 16 different model types. And so right now, Ray doesn't have great support for doing this queuing mechanism of making sure that these jobs get run and then you can retry them. But this is something that has been sort of commonly requested. And right now, I would say the closest thing to this is actually just to use Ray-Tune, which has this sort of internal queue for different trials, the different models that you can train. But yeah, if you could again also voice this on, we're very active on GitHub. So if you want to go ahead and voice voice this sort of feature request on GitHub, and then tell us a little bit more about what you're using Ray for and why the job queue would be really good for your use case. I think this is something that we would be more than happy to prioritize. Right. Yagia has the. Should I keep going?
Yeah, let's go down the list of
Wonderful.
questions.
Keep going.
Yeah, Yagia has a question, which is, well, I guess, yeah. Ray for edge computing. I think this is like something similar to the previous comment about AMD GPUs and AMD devices, like where, yeah, we're working on support for the ARM builds, and that would basically enable Ray for edge computing. Pseudomaze has a question. Are you planning to have, I guess the first question, there was like, are you planning to have a dashboard to look into Ray processes? This is very interesting. We do have a dashboard that gives you high-level metrics, but in order to get introspection into the processes, we do have to add a little bit more additional support. And so right now, I think there is a option of like doing an inspection, but that sometimes doesn't work because it requires like elevated permissions when running your Ray cluster. So I think basically the answer is like yes, sort of. But if you could tell us a little bit more about like the constraints that you're operating in, that would be useful for us to provide maybe perhaps a workaround or at least do a little bit of investment on our side to support this feature.
Nice. It looks like Pseudomaze has a second question. So Airflow
with Ray to manage jobs. This is like related to the question about job queues. So Ray Airflow is a workflow orchestrator, which allows you to run multiple jobs and run them in some sort of sequence, right? And so so there is some work that we're doing in collaboration with the Airflow team for building Ray applications with Airflow. But yeah, Airflow with Ray would be another solution for a job queue. Yeah, so the next thing is, Alamoon asks about benchmarks for Ray versus Horovod. That's a great question. In fact, there are no benchmarks for Ray versus Horovod, but actually, you can actually run Horovod on top of Ray, which is essentially going to give you no performance degradation. And because like basically Ray serves as a lower level layer, or like I guess a higher level layer on top of Horovod. You can do distributed training with Horovod, but you can also get the simplicity of programming, the programmable simplicity of Ray when using Ray Horovod together.
And there's a couple talks that happened at Ray Summit. Travis Adair, I believe, gave on Ray and Horovod together. So great talks.
Cool. And then I guess there's
Michael follows up with a question.
Yeah, Michael has this question. Any plans to add the serve batching support to Ray auto batching? That's interesting. I think actually there are some certain components of the Ray library or like the Ray utilities that provide auto batching. So one example is like the Ray, I think it's like the actor pool or like multiprocessing. There's automatic batching within those like modules of Ray, and it's very similar to like serving, or like a little bit similar to the value the features that you have in Ray Serve, but you can use them outside of the context of Ray Serve.
We have one question slipped in from. Thanks for the question, Michael. From Jason. So what is the benefit of using Ray for PyTorch distributed training versus PyTorch native distributed training?
This is a great question, Jason. So I think, right, so what you want to think about is how you plan to use Ray, or how you plan to use the distributed training in whatever context that you're using it in. So for example, like if you want to do something like you want to do distributed training as part of a larger workflow, right? Like let's say you want to do like some like data processing stuff, and then you want to do distributed training, and then you want to like take that model and take it somewhere else. If you were to use PyTorch native, the API the interface, the programmer interface that you're able to use is like this Torch launch module, which ends up being a little bit clunky in some sense. Like forces you to rely on something that is not Pythonic. It forces you to rely on like shell scripts to chain everything together. Ray PyTorch allows everything to be Pythonic. So you can do some data processing, throw it to like PyTorch on top of Ray, which is like Ray SGD essentially, and with minimal code changes, right? And then you can do your distributed training. Then you can come back out and then like do some like model post processing or whatever, all within one Python script. And there's a huge benefit for doing this because now like things become very easily unit testable, right? Then things become very easy to work with because now everything's just in Python and you get the same sort of Python ecosystem within one sort of end-to-end workflow. I would say another thing is that like with Ray SGD, there is like pretty good fault tolerance support, which I know Torch Elastic has now. But previously, this wasn't the case. It was sort of hard to do fault tolerant training with PyTorch.
Interesting. Wow, it's a good list of questions coming. They just came in. So I guess we are coming close to the end of time. But do you guys have any parting words you want to leave our audience with?
So the biggest thing for me is if you have a feature request or you have some issue with Ray, put an issue on GitHub. We're always looking for contributions, various types from people all across the world. And second, if you want to learn more about Ray, there's the Ray Summit page, and we have so many talks about using Ray for data processing, serving models, using Ray with a bunch of different libraries together in conjunction. So please check out Ray Summit page. All the talks from Ray Summit 2021, which I believe happened June 22nd, 24th, they are all going to be on YouTube within like a couple weeks. So keep your eye out for the YouTube channel and let us know if you have questions. What about you, Richard?
Yeah, I mean, I think my take, if I were a listener, one of the takeaways I would have is I would want the listener to have is that Ray and PyTorch actually play very nicely together. They're not at all like at odds, and if you want to get started with Ray and sort of get active in the Ray community, there's there's a variety of different channels that you can participate in, including the Ray Slack, the Ray Discourse, or the GitHub. And like the Ray community is pretty large, maybe not as large as PyTorch, but everyone's very, very happy to be here and very excited to help out.
Nice. Well, yeah, we were very excited we were just really happy to have you guys, Michael and Richard, on today to talk about Ray. I think, yeah, it's been also very invigorating for you and myself just to hear just the breadth and the scope at which Ray is helping various projects build out. So for those who are watching, yeah, please make sure to follow Richard and Michael. Their Twitter handles are next to their names, so follow them there. Check out the GitHub, which we've kind of shown a couple times. It's also linked down in the show notes, and then we'll also be sharing the notes that Michael had posted throughout the presentation. We'll add those down below. And again, if you enjoyed watching this episode, please make sure to like and subscribe, as every good YouTuber will say, so you'll be notified of future episodes. And yeah, make sure to drop suggestions of any future guests that you love to have us have a chat with. So with that, I guess we'll wrap it up for today. And yeah, see you guys next week. Bye, everyone.